Hello everyone, welcome back to the session on closed loop testing. I am Steffi J. Stephen, PhD student working in the Department of Civil Engineering. Today I will be showing how the testing of compression is done in the closed loop testing machine. Here we will be getting the complete stress strain curve of concrete under compression. So, we need a cylindrical specimen for this, and the dimension of the specimen should be maintained in such a way the height to diameter ratio is always less than 2, and the testing is mainly controlled by means of circumferential strain control in order to maintain stability during the testing process. So, these are the accessories required to do the testing. We have an undeformable chain which will be placed around the specimen, and an extensometer will be connected to this chain to record the change in chord length. We have two axial extensometer which will record the axial deformation of the specimen. So, before starting the test you have to measure the diameter, initial original diameter of the specimen. And we are measuring the height of the specimen. Now, we have measured the height and diameter of the specimen. Now, I will mark the specimen to attach the extensometer. So, we draw a straight line and we will mark the center of the specimen. In our case it is 195 mm. So, I will be marking So, I am marking the center of the specimen. Then in order to attach the extensometer, the extensometer gauge length is 100 mm. So, I will be marking 50 mm above and 50 mm below the center point. So, similar way we will mark on the opposite side. Now, the specimen is marked. Now, we take the specimen to the testing system and start the testing. So, this is the closed loop testing machine in which we will be doing the compression test. This crosscut can be manually moved by means of this manual controlled lever arm. The capacity of the machine is 1000 kilonewton, which is powered by hydraulic unit. The actuator can be moved with the help of the software in the system. So, we also have an LVDT above the actuator which measures the movement of the piston. Now, we will attach the extensometer on the specimen. So, the one end of the chain will be attached to the extensometer. And we will place the chain around the specimen. Now, we have to elongate the extensometer so that we can connect the other end of the chain. check whether the chain is kept at the center of the specimen. We will place the extensometer on the markings. So, by using a rubber band, we are fixing the extensometer in place. The blades of the extensometer should be placed on the markings. Similarly, we are placing the another extensometer. While placing the extensometer, make sure the pin is on the extensometer, and before starting the test, we have to remove this pin so that the extensometer deforms. Now the testing setup is ready. The circumferential strain is going to be measured by this extensometer, and the axial deformation is going to be measured by these two extensometers. In this test, we will control the testing by means of the circumferential control. This is done because the circumference is going to always expand, whereas the axial deformation will always compress. But what happens is, if there is a crack occurring near the extensometer might slip off. That is why we are using this circumferential control in this testing. So, first the controller has to be switched on. After that, we will open the software called Station Manager, which will control the testing. So, this is the software used for the testing. First, we have to switch on this exclusive control so that we can use this two icons. First, we will switch on the hydraulic power unit, which supplies the oil to operate this machine. Then we will be switching on the HSM. So, before starting this test, we have to always ensure the active mode is displacement in the manual command. Then we will move the piston to 110 mm. The maximum displacement the piston can move is 125 mm. Now, we are moving the pistons to 110 mm, thereby the piston can move 15 mm below. This we are doing in order to make sure this we are doing because due to some instability, if the piston suppose comes down and hits the ground, there is no we are placing the piston at 110 mm, thereby the piston, if due to some instability comes down also, it does not hit the ground. This is for safety purpose. Then now we will open another software called multipurpose Elite. We are opening a template which is already programmed. In this software, we can program the steps to be done during the testing. First, initially the test will take place under load control. Then we will be switching on to the chain extensometer, that is circumferential control. We will be gradually increasing the rate of loading and the data will be acquired in each step. Deformation of about 6 mm. Then the test will stop and the piston will remain in the same position. In the meantime, we will be removing all the extensometer from the specimen. Then after that the test will start and the piston will keep on moving. Now it will be the piston deformation controlled. So once the load has reached 2.5 kilonewton, the test will stop. The specimen should be grinded or capped before testing in order to make sure the surface is smooth, otherwise there will be irregularities in the specimen because of casting and stress concentration might occur and you will not have uniform loading on the specimen. Now the testing is complete. From this test we can derive the Young's modulus of concrete. We can derive the Young's modulus of concrete from the linear region, and you can calculate the compressive strength of concrete. By using the axial and circumferential strain, you can calculate the Poisson's ratio, and you can also calculate the compressive toughness, which is the area under the complete stress strain curve. In conventional testing procedure, this type of result is not possible, where you can get the complete stress strain curve. By using closed loop testing, you can have a stable control and get the complete stress strain curve. From this graph you can see, first initially the stress is gradually increasing linearly with strain, and then it is kind of having a non-linear behavior when the micro cracks are occurring. Then this micro cracks joins together and form a single crack, and crack localization occurs when the peak load is reached. Then after the peak, the stress gradually drops down, and the test is continued until complete failure. So now you know the major advantage of closed loop testing, and using this kind of test you can find the complete compressive behavior without omitting in the useful post peak part of the concrete or any type of specimen, and you can do design accurately. Thank you for listening.